Hey folks, Rick Claus here from Microsoft, and I'm very excited to be able to welcome you to the Windows Server Summit. In case you didn't know, we celebrate our 30th anniversary of Windows Server, and we decided to evolve the Windows Server Summit to include more content over a larger number of days. We partnered with engineering teams at Microsoft, our friends at Intel, and the MVP community to be able to generate over 30 different technical sessions covering hybrid cloud, Windows Server features and functionality, security topics, and even hardware advancements that are part of the Windows Server ecosystem. Don't forget, during the session, you are going to be able to get your questions answered during the sessions as they go live by asking your questions in the comments or interacting with us on the interactive chat. Your call how you want to do that. But I want to take a moment here and introduce our keynote. It's a conversational keynote between Jeff Woolsey from Microsoft and Andy Vargas from Intel, talking about how the partnership has evolved over the years and where it's going to be going in the future. Take it away, Andy and Jeff.
Greetings, everyone. I'm Jeff Woolsey, Principal Program Manager here at Microsoft, and a huge thank you to all of you attending this year's Windows Server Summit. I am thrilled to be joined by Intel Vice President and GM of Microsoft Technology Center, Andy Vargas. Andy, thank you for being here.
Thank you for having me. Appreciate it.
Just awesome. There is so much going on in our partnership, in technology, in innovation, whether it's cloud, whether it's on premises, whether it's the distributed edge. We've got a lot to cover. We are really thrilled to present this comprehensive three-day event featuring demos, technical sessions, Intel sessions, sessions from our MVP community. We have a lot lined up and we are excited to be able to do it. Our agenda includes exploration of new technologies and capabilities in Windows Server 2025, a look at in-depth hybrid with Azure Arc, advanced security. We've got a lot to talk about there, as well as hardening the platform.
That's right.
I mean, this is, again, one of those areas of innovation where Microsoft and Intel, working together can really drive the leading edge of innovation for hardware and software together.
And I'll cover a little bit of that in my section.
Awesome. I also want to point out, I know Rick probably mentioned this, but we are hosting live Q&A sessions throughout the event. So we encourage you to actively participate, whether it's watching, learning, and even please contribute questions. We want this to be interactive. So as we begin this Windows Server Summit, I really wanted to impart a few very important points about Windows Server. Number one, Windows Server is important. And we want you to know that we understand Windows Server is important to you, but I also want you to understand that Windows Server is important to us. Organizations around the world, we understand you rely on Windows Server for its built-in applications, as well as its ability to be a runtime for mission-critical workloads. I mean, look at all the work that we've done for SQL Server, for example.
Right.
We've been doing this for 20 years, and we continue to find new ways to innovate even further.
There's always room for innovation. The computing needs continue to grow, and together, we had tried to address that for our customers.
Yeah, and so we understand that organizations rely on Windows Server. They rely on us to take advantage of the latest in hardware advancements, the latest capabilities for storage, for networking, and like I said before, the built-in applications. Don't forget that Windows Server Active Directory is the industry standard used by organizations literally around the planet for identity and authentication. But it's not just AD, it's Hyper-V, it's File Server, and more. I also want to point out that we use many of these core OS technologies throughout Microsoft, like Hyper-V, for example. Sometimes features begin in Windows Server and percolate into Azure. Sometimes features begin in Azure and percolate on premises into Azure Stack HCI and Windows Server 2. So it's critically important, Windows Server, not only to you, but to us. I also want to remind everybody, we are constantly innovating Windows Server and we are investing in Windows Server. And over the course of the next few days, you're going to see innovation across a real broad range of technologies, from AD to Hyper-V to storage to software-defined networking to containers, clustering, file servers, hybrid cloud, and so much more. Finally, one really last important thing. I want to make sure you understand, we want to meet you where you are. So do you want to run Windows Server on physical hardware on premises? Do you want to run Windows Server on massive monster scale-up systems with hundreds, if not thousands of cores? Do you want to run it on small edge devices? Do you want to run it virtualized on Windows Server, on VMware, on Azure Stack HCI, on Nutanix? Do you want to run Windows Server in Azure? Do you want to run it in another hyperscale cloud, a local hosting provider? Do you want to run it cloud connected? Do you want to run it disconnected? My point is, wherever you want to run Windows Server, we want to make sure it runs great and that you're able to achieve your goals. All right, with that, we have so much innovation lined up over the next few days around Windows Server, and I know Andy has got some things that we've been working on together we're excited to talk about. But I really wanted to take a moment to talk about how the building blocks of innovation of Windows Server have really culminated in where we are today. And it really begins with the NT family and delivering server for the masses. A lot of people don't recall this, or maybe this is new, but before the advent of NT, servers were generally limited to large organizations with deep pocketbooks running mainframes.
Yeah.
It was crazy when all of a sudden Microsoft and Intel said, no, we want to bring servers to the masses.
That's right. And I recall, because in my own journey, I've been working on and with you guys for 24 years. I started on the server side, so NT was one of the things I started with. I actually started with 351 that came before. So yes, NT was sort of that big moment for us together to sort of really get servers and that whole server mentality out in the market.
Yes, and making it broadly available. I mean, it's literally enabling server for the masses. Up until then, it was, you were a large organization, you had these big mainframes, you were running Unix, it wasn't friendly, it wasn't familiar, and in fact, that was one of the things that really Windows NT 4 brought to the table, which was that familiarity, that Windows 95 look and feel, which all of a sudden made ease of use and helped customers realize, wait a minute, I can use this thing, it's solid, it's reliable, it has all of these interesting facets, and by the way, I can start developing on my client and deploy it on my server. And all of a sudden now, people are using Windows Server with commodity hardware for file, print, and company-wide applications. And if you look at Windows Server and what it brought in terms of capabilities, 32-bit computing. I know that sounds almost quaint today.
Yes.
In fact, it does sound quaint. It just does. But back then, you have to remember, with 16-bit computing, memory limitation, memory addressing was scarce.
That's right.
All of a sudden, we had a full 4 gigabytes. I mean, Andy, come on, that's crazy. I wouldn't even run a laptop these days with 4 gigs of memory in it. But that 32-bit computing enabled a lot of different things. Not only did it enable us to address more memory, but it allows the CPU to do more efficiently, more calculations per cycle.
That's right, more compute. You were able to sort of address more, do more. But I think the more important piece of that is to just start us on this journey of innovation.
Yes.
Right? It was server, it was 32-bit, but as you'll go through, we didn't stop there.
Oh,
and
no.
We're still going.
No. This was really just the tip of the iceberg for Windows NT 4 and how we have progressed over the decades to where we are today. But 32-bit was a game changer, opening up a large memory at the time. Right. It also supported multiprocessing. And it's funny that I say multiprocessing because back then, folks, cores did not exist. There was no multi-core system. It was a single processor with a single thread of execution. There wasn't even hyper-threading back then. No. It was literally, here's a processor running a single thread of execution. NT supported SMP. So all of a sudden now you could actually run, guess what, multiprocessor on commodity hardware. So again, another game changer. And a big one would be things like reliability. And of course, we also introduced multi-user support. So all of a sudden now, this was something that companies and larger organizations were very much interested in from a business standpoint.
And I think the important piece there is not just the multi-user, but the different types of users. Right?
Yes.
You can have an administrator, and you can have users that didn't have the same sort of access.
Yes, yes, you could grant different permission levels and access controls. Back then, it was still pretty granular. We made it more granular over time, but totally agree with you. But again, this was really the stepping stone for beginning server for the masses. Really what Windows NT did was it also set the foundation for the next era of Windows Server, the Y2K and Enterprise era. And really, this was a pretty amazing time because really the world was, responding to the Y2K issues. And there was a lot of work done by a lot of organizations led by governments to make sure that we want to minimize any potential impact from the Y2K bug. And while that was happening, we embarked on an era defined by enterprise-grade capabilities. For example, NT did some great things for reliability, but we needed to massively improve that. We needed 5 nines.
Right.
We needed some serious uptime. And it meant that also from the hardware perspective, we needed to work closer to making sure that what do we need to do in terms of the platform, in terms of memory, in terms of processor support, to take this to the next level in terms of reliability, scalability, and even accessibility. So Windows Server, one of the great things I like to point out is it introduced a technology that quite honestly most organizations all use today, Active Directory. Active Directory, it's the standard by which organizations do identity management, authentication. It also introduced group policy. Again, another IT pro, sysadmin's best friend, group policy and Active Directory. And these core innovations continue on to today. Like one of the questions we will get about new releases is, have there been any changes to forest functional levels and domain functional levels? Have there been any changes to group policy? And guess what? We've got a lot to talk about this week with Windows Server 2025, because there are changes coming in this next generation of Active Directory. Windows Server 2003 built on the foundations of Server 2000 and included a significant investments in storage, both local and SAN storage.
That's right.
As well as the launch of the .NET framework, which really, kickstarted a prolific wave of application development utilizing technologies like .NET framework, ASP.NET, C#, and it was a boon for folks that needed to develop new applications quickly and reliably and take advantage of these new capabilities. And finally, the very last thing was the very last version of Windows Server 2003, we actually introduced the first 64-bit version. So it was really kind of the dawn of 64-bit. But it didn't go mainstream quite just yet.
No, you supported both still at that time.
We did. We had both, and 2003 was great because it allowed us to work together and identify new areas of innovation around security.
Right, but I think something that you mentioned earlier is this is another way that together we met the customer where they were, right, or where they are. We didn't say 32-bit was gone and you only have 64. There was still some customers who were 32-bit, some that were willing to move forward to 64-bit, and then as the industry transitioned, then we got to a new point where it was 64-bit.
Well, and I totally agree with you, and I think this has always been something, we really listen to your feedback. We really want to understand how you're using Windows Server, what features are important, what features are less important, what things you need, and we're always trying to anticipate those needs, as well as make sure that we're making those right decisions based on your input. And 2003, the 64-bit is actually a really good example. 64-bit, no one was really clamoring at the door quite yet. People were still used to 4 gigs of RAM in the 32-bit world and some of the limitations there. But there were some workloads, SQL Server large databases, virtualization, where, oh my gosh, you absolutely want 64-bit. Virtualization was, up until that point, was super hamstrung by 4 gigs of RAM. 32-bit support for virtualization was a major problem, and it was why the very first 64-bit technology we released at Microsoft was Hyper-V, because we needed to take advantage of all that memory address space, all those cores, and all that hardware technology that was enabled through 64-bit. So the the 2003 enterprise era, this really ushered in the next wave of innovation in the data center, which was the data center era. And Windows Server 2008, it really marked a pivotal juncture. It established the data center era with a whole bunch of groundbreaking investments and advancements. This is when we introduced and integrated Hyper-V virtualization into the platform. It was no longer this separate thing you had to buy and pay and add on, and it was literally, no, I check a checkbox, I reboot my system, and now I'm running virtualized. And it marked the transition, 2008 R2, marked the transition completely to 64-bit.
64-bit only.
And this goes to the point you were saying, which was around compatibility. And this was an important point for us, was we knew that when we made the shift from 32-bit to 64-bit, no customer is going to want to throw out all of their existing apps. They don't want to have to recompile or rewrite or whatever. No, we spent a lot of time working together to make sure that we had this ability to run 32-bit apps on 64-bit Windows. It just runs. It simply just runs. And it's a testament to the work that we did together to make sure that that compatibility was rock solid. And today, 64-bit is the stock, is the standard.
Right, and I think one of the things that maybe a lot of people don't understand or don't know is that some of these innovations take years. It starts as an idea and a need and a problem, and then how you address that problem, how you approach that problem, and more importantly, how it deploys and gets supported over time to meet the customer need is really where you have to think all the way through in order for it to be a viable product.
Well, and this is one of the interesting things about our partnership is I've learned over the years, software, we got lots of flexibility. We can make changes, we can patch, we can release updates, we can do all sorts of things in terms of speed and making changes to the platform. CPUs, hardware, you guys are planning way out in advance.
That's right.
And I've sat in these meetings where you say, hey Jeff, by the way, this is something we're delivering in 3 years. We need the OS to be ready. We need to be ready and plan for this, and here are the benefits you're going to get. And I'm sitting there going, this is 3 years out. But it's like, well, yeah, because their silicon, your scheduling is completely different than software.
That's right.
I totally respect what you guys do.
Yeah, and I mean that just it emphasizes the need for the partnership. To talk early because as you note, hardware and software schedules don't deliver on the same cycle. As a matter of fact, I don't know that I ever recall them actually landing up exactly the same launch date.
Oh,
maybe a few times, but I'm not sure.
This is such a hard thing. I have to admit, it can be so hard because you've got your schedules, we've got our schedules. We're trying to make sure that we're lighting up the latest hardware advancements. Sometimes it's CPU, sometimes it's chipset, sometimes it's security, sometimes it's something else. We're trying to light those up. We've got to meet all of our testing and validation. You send us test hardware. I mean, there's a whole dance that we have to do to test and validate and develop new features and develop the platform and expand the platform. And again, I have great respect for what you guys do on the hardware side. And it also, again, speaks volumes to the partnership that we've done so much. And I do know some stuff that we're working on in 2 and 3 years, and I'm very excited about it. No, I can't talk about that today.
Correct.
Getting back to where I was here for just a minute, 64-bit becomes mainstream. All of a sudden now, applications, SQL jumps all over this. All of a sudden, SQL and database is unlocked. It's like, wait a minute, I'm not limited to 4 gigs of RAM anymore. I don't have to do any of these special PAE extensions or anything like that. I remember this from the way back
36
days.
bits.
Yeah. No, I got 64-bit, baby. I got tons of memory now. So all of a sudden, databases have huge amounts of memory to work with. All of a sudden, virtualization has all of this memory to work with. All of a sudden, I can run more virtual machines, take full advantage of that. And then going from 2008 R2 to 2012 and 2012 R2, this was a huge boon because at this point, the hardware innovation was now in full swing. So we had multi-socket, we had multi-core, we had large memory, we were usually connected to very large storage arrays. So I/O was critical, memory was critical, scheduling was critical, and we introduced advancements really throughout the platform for performance, for scalability, for automation. And it really was, this data center was really amazing what was going on here. And on the storage side, we were also very busy over there. We really had a tour de force. We released our first storage virtualization with storage spaces and the introduction of the SMB3 protocol. And this is another good example of a technology and a protocol that is absolutely 100% used today. We've been continuously innovating on it, and we're going to talk about it a lot this week with Windows Server 2025 because we're doing some amazing things over there in terms of next generation SMB and how we're locking down and hardening the platform, as well as other interesting protocol conversation that's going on. And then finally, on the Hyper-V side, I also want to point out that it also underwent a pretty huge transformation in the 2012 R2 days. So every form of live migration was included: live migration, storage migration, live storage migration. We were also the very first hypervisor to do shared nothing live migration, which literally meant I could live migrate a VM from one server to another server without any shared storage or without any clustering. All you needed was a network. So we were the first ones to do that way back then. We also introduced Generation 2 virtual machines, where the VM itself now became almost fully synthetic. Everything there is based off synthetic hardware, synthetic drivers, which meant we could do things in terms of performance, in terms of security. We implemented UEFI firmware. So it really, Hyper-V took some real large leaps and bounds here in the data center era. And finally, the cloud era was about to leave these improvements in the dust. So as awesome as the data center era was, it's like crazy what's been going on since then. So we've seen a paradigm shift. Back in the data center era, VMs were king. That's all anybody cared about. Back in the 2012 era too, everybody wanted to talk about virtual machines. That's changed. That has very much changed. Now don't get me wrong, virtual machines, everybody still loves their virtual machines, don't get me wrong. I love my virtual machines, okay? But containers are here. Containers are real. They are very much happening. It's a transformative inflection point that we saw. We saw it on the horizon. We said, we've got to put this in 2016. We need to have Windows Server containers. And we saw this reflected through our cloud use. The Azure Kubernetes service is one of the fastest adopted cloud services that we saw from customers in Microsoft history. And so we wanted to make sure that Windows Server, guess what? We can plug in containers, and we even provided different container types. We also introduced different types of isolation. We introduced standard process isolation, which is something that's been available in open source, but we also introduced Hyper-V isolation, which gave it another level of protection and security and isolation that you don't normally get in process isolation. Windows Server 2016 included a whole bunch of features across the board in failover clustering and production checkpoints for Hyper-V. We introduced network virtualization. I mean, across the board, so many things going on for software-defined networking, software-defined storage. At the same time, when we talked with customers, we were kind of trying to understand what does your cloud journey look like? Like, what is your plan? Are you going to move everything to the public cloud? Are you going to keep everything on premises? Spoiler alert, the answer is everybody's kind of in the middle. If you look at multiple surveys, the Flexera State of the Cloud, for example, they find that I believe it's 75% are, yeah, we're doing hybrid cloud. Almost nobody is doing completely private cloud anymore. That's almost completely gone. I think it was down to 1%. And there are a few people that are doing fully public cloud. I think that's in the 20% realm. But most people are doing hybrid, where they're basically saying, oh, I'm absolutely moving a bunch of stuff to the cloud. In fact, I want to move as much of it as I can, but there are some workloads that I need to have on premises for security, for governance, for latency. And what happens if I want to do inferencing at the edge? I want to take advantage of ML. I want to take advantage of AI. And I actually don't want to pump and pipe all of that into the cloud. I want to be able to do that on premises locally and do that local compute. So there's a tremendous amount of innovation that we've been doing around hybrid cloud services because we want to make sure that you can be successful with Windows Server wherever you need it to reside. And we delivered it in a number of ways. Of course, we have Azure Arc, and you're going to hear a lot about Azure Arc this week. It's an amazing technology that's really opening the eyes of a lot of folks for ease of management, ease of security, policy, governance, and so much more. We also have capabilities, hybrid cloud services built into the platform, like the storage migration service. I love this. Azure File Sync that can give your file servers virtually bottomless storage. And so we're listening very carefully again to understand what are those things that you need to be successful. Another good example is, of course, Azure, Active Directory connectivity into Entra ID. You can, of course, synchronize these, as most organizations do, so that you have a consistent identity and authentication management. So Windows Server 2019, we delivered a ton in terms of containers. We introduced the Windows subsystem for Linux. We introduced a whole bunch of new features with Kubernetes support. We had storage migration services. We introduced shielded virtual machines for security. Windows Admin Center, OpenSSH. I mean, just an embarrassment of riches. And so finally, we get to, really Windows Server 2022. And this one, security was a big focus for us. And this was an area where, again, Intel and Microsoft said, look, we want to advance the state of the art. The bad guys, the actors out there in the world, whether they're nation states or organizations, whomever they may be, the bad guys are trying to get into your servers. And they are looking for vulnerable points. And one of the things we want to do is we want to harden the platform all the way down to the firmware. Like the moment you turn on the power button on a server, we want to be able to measure and attest that entire boot process all the way till there's handover to the OS, and even then we enable things like virtualization-based security.
That's right.
And so we introduced this swath of technologies in Secured Core Server, which was a huge deliverable in Windows Server 2022. With Secured Core Server, it actually protects against classes of attacks. Like there are some attacks that you simply cannot even do against a Secured Core Server. It's just simply not possible. So we introduced Secured Core Server for file servers and application connectivity. We introduced SMB encryption and compression mechanisms. We also introduced an extended container support. I also want to point out one of the other huge benefits about containers, which is portability. I think a lot of people miss this. And like virtual machines that are portable, I can easily migrate them, live migrate them, all of that. A container is really just the application and its dependencies. And one of the beautiful things about containers is once you have a containerized application, I can drop it on Windows Server 2016. I can drop it on Windows Server 2019. I can drop it on Windows Server 2025. Guess what? It just works. And when Windows Server next version after 2025 comes out, guess what? I can drop a container on that because it's decoupled from the operating system. And so containers, Kubernetes, hybrid, software-defined compute, storage, and networking, these are all critical things in the cloud era. And so lastly, I also have to point out that Windows Server 2022, to embrace the cloud era, we actually introduced a special edition of Windows Server. It's Windows Server 2022 Data Center : Azure Edition. And I apologize for the name. It's actually not a name, it's a paragraph. Right. But the reason why it's so long, I know people always ask me, come on, Jeff, come on, Microsoft, do better than that. There's a reason. It has all of the data center features, and then we added some additional features for Azure Edition. For example, hot patching. With hot patching, you literally can patch a server while it's running without downtime. This is available with Windows Server 2022 up in Azure today, right now as we speak. We have customers, we have teams, we have organizations. Xbox is using it. They're running over 1,000 mission-critical SQL servers all up in Azure, and they're hot patching, and they are absolutely loving it. Now, for folks who say, yeah, Jeff, but I'm in a hybrid world, and I need hot patching on premises, that's okay. You can use Windows Server 2022 Azure Edition on Azure Stack HCI, and you can get hot patching on premises. Now, even with all this said, folks said, yeah, Jeff, this is awesome, this technology, this hot patching, we need this everywhere. We need this on premises, we need this in other clouds, we need this on physical. And the physical one, I totally knew exactly what this was. Think of the old school SQL team, and by old school I mean they deploy SQL on the metal. Mm-hmm. They come into you, Andy, and they're saying, Andy, how much memory can you put in your servers these days?
That's right.
How many cores can you put in your servers these days? Awesome. We're going to put SQL directly on the bare metal because we are going to use every ounce of processing resources, storage, I/O, compute that you can give us. And if there's anything else, we'll take it. Okay? So when it came to people saying they wanted hot patching on physical, I knew what it was. It was scale-up SQL Server.
Yeah.
I mean, think about these servers now that have not gigabytes of RAM, but terabytes of RAM. People don't realize, you know how long it takes to reboot a system with 8 terabytes of RAM, 12 terabytes of RAM, 24 terabytes of RAM? This is like over a half hour, 45 minutes, over an hour, people. It takes a long time. So if I have to patch a mission-critical SQL server every month and a reboot, sure, I'm clustered, I'm going to do HA, and it'll be done without any downtime. But you telling me I can hot patch it, I don't even need to reboot it, that's like next-gen stuff.
Right.
So you're going to hear all about the innovation coming with hot patching and making it available to everyone, everywhere with Windows Server 2025. So I hope this little trip down memory lane, I know this was fun for me, I hope this was fun for you. And the thing I want to point out is, number one, Windows Server 2025 is driven by you, okay? It started off being the server for the masses, but once everybody had it and was able to consume it and take advantage of it, that's when the direction was like, okay, customers say, I need virtualization. I need storage virtualization. I need high-speed networking. I need more cores. I need large memory support. I need you to support these apps. I need you to do X, Y, and Z. We do this based on your needs. And you can see how they've built on each other. Active Directory from 2000, we're going to talk about it in 2025. Hyper-V from 2008, guess what? We're going to talk about that in Windows Server 2025, and how we're taking Hyper-V and enabling GPUs and AI for the next generation of Hyper-V and AI workloads. So with that, Andy, I got to say, I've been having a ball talking with you about software. We need to talk about hardware. I know there's some really exciting stuff coming with Xeon, and I just want you to take it away, Andy. Tell me what's going on in the world of Xeon these days.
Yeah, so before we get to that, I mean, part of where I wanted to start is, you talked about the journey of software and the industry, and I think what a lot of people out there may not know is how the partnership helps us get there, even with things like you were talking about hot patching. There would be hardware elements, firmware elements, and so we have to work together to make sure that works seamlessly, for the customers, and for the solutions that they want. And so when we talk, Microsoft and Intel, we talk about like, how do we innovate? The process of innovation, how do we actually do that? And I'll talk a little bit about that. But really it's with the goal of accelerating different pieces to market. Right, and I'll talk a little bit just about performance and security, but you've covered way more than that, right? And then there's also this, like, we drive to this, but it's for a reason. It's to get solutions, right, out to the market. It's to make sure that we're getting out there in a way that addresses the customer needs. It makes it a modern infrastructure, right? So when we talk about innovation, I mean, going back to what you were talking about, this really took me back. We had single core, then there was actually dual core. It wasn't even multi.
Yeah,
that was there for a
dual
while.
Core, that's right.
And then you had, multi-core, and then like you said, you had threading, and then you started out with bare metal, right? So everything ran on the hardware. Then had virtualization, and that's one of the things when I was doing more engineering. That was one of the things that I worked on with you guys, and it took us years to develop the right technology so they can do all the things that we needed. And we also started, as you stated, individual servers, right? Data centers, and now the cloud. All of that takes partnership and innovation together. And many times we start down this partnership path is really with a problem, right? It's a customer problem or a technology problem, or we need more uptime. The systems can't go down anymore. Everybody's so dependent on zero-time access, right? And so we actually sit down and talk about the solutions that we need, the problems they're going to address, how we should build it, what is it going to do, and how will people use it?
Yes. Right?
Which is a really important part. And then what value will it have for the customer? Because we can innovate and design and bring to market new things, but if they don't have a purpose for the customer, it's not going to do well.
Yes.
And when I think about that, it's not only from like idea, but it goes all the way through support. I mean, you talked a lot about support and policy, and so it has to maintain the whole life cycle of the innovation. And then from a how do we actually do it, we have really strong long-term engineering engagements at all different levels. You were talking about storage, we have an engagement there. You're talking about Hyper-V, we have an engagement there. You talk about reliability, we have an engagement there with Windows Server, Azure Stack, Azure, right? To make sure that we're, together with you, building the right products for the customers so that together it operates as best as it can. And we always start with an idea, then we have to go show proof of concept. Is it going to work? We have a lot of really smart engineers, and sometimes you get to it working faster than others, but you get to this point where you have actually a proof. And then, as you make progress, you get to actually something that's more in depth, more rich, like a prototype. And that's where you were talking earlier. You get early hardware and early software, and you actually put them together between our two companies, and you actually have to test it. You got to make sure that it's going to meet the expectations that we laid out. And what you find is initially there's room to grow, there's room, work to do, and so that's where the tuning comes in.
Well, and that testing for just a moment, that I think is another really important aspect, because in server world, I have to constantly remind folks that love their laptops. They're like, well, isn't a server isn't it really just kind of like, no. We've got dozens of cores, we've got terabytes of RAM, we've got multiple memory channels, we've got PCI, we've got I/O everywhere. And so for us, we have to jointly test and validate small devices, medium-sized devices, data center devices, massive scale-up systems where you're talking multi-processor with many, many cores and tons of I/O, and you have to do it under stress at scale.
That's right. And I think that the thing that we've learned as we've gone into this cloud era is the at-scale portion. What you used to be able to do for servers or even data centers and clusters of that size, not longer sufficient for sort of this cloud era that you were talking about. I think, but as we get to tuning and optimizing, that's really when you kind of start putting the finishing polish on the solution. And then finally you get to deploy and ship it and have the customers use it and enjoy it. But, at the same time, this industry moves really fast. Computing needs grow day after day, day following day. And we have to accelerate what we do.
Yes.
Right? And so all these really strong engineering engagement points really help us to not only innovate, but to accelerate the things that we need to get done for our customers. And I'll talk about a couple of places that we do this. It's like performance. Computing, back to your 4 gig, 32-bit, right?
How
computing needs just continues to just to march on and grow, and everything will be needed. It's astounding from when I go back to when I started.
I have laptops with 64 gigs of RAM.
Yeah,
I know guys that carry even bigger ones, but I have laptops with 64 gigs of RAM, and I remember when that was a big deal for server.
Oh yes.
That's my laptop.
Yeah, but just like we really take a thoughtful look at how we innovate, we think a thoughtful look at how we accelerate, and we look at performance, and it isn't just about the fastest piece of software or the fastest CPU. You were talking about balance in a way earlier, where you were talking about I/O and storage and network. And so you have to look at all aspects of the platform, from the CPU to memory to I/O to accelerators, and make sure that whole group is advancing in a way that's going to give you and allow you to capture the performance that you're trying to achieve. Then comes at the same time, the software. Given your comments earlier about software can innovate in a much faster pace than how hardware is delivered. You got to optimize the software. You got to change it sometimes, right? You got to patch it sometimes, right? And so it really becomes super important to look at the end-to-end needs on performance, and then hit that mark both with the hardware and the software together. That's how we get there.
Yeah.
Right? And then the reason we do it at all, it's very challenging, and there's a lot of engineering excitement about doing it, But it's really to drive solutions to the market. It's really about solving problems that our customers have, that we need to get there. We need to get there fast for their needs. And it's really about modernizing the infrastructure to address the problems that customers have today and that they're going to have tomorrow. I mean, this is part of where your journey came from. Starting from the beginning is we had compute, we turned it on, we did more, and then all of a sudden it's like you feed this pipeline in from the customer feedback, and now you're building things and solutions that actually address real world problems for them. And that's the essential piece of how we work together and innovate.
I love it, and I could not agree more. It's one thing to do engineering and innovation for the sake of it, doing engineering and innovation, but are you solving a real customer need? Are you solving a real organizational problem? How can we transform and leave the world in a better place? And we are constantly looking at ways, how can we deliver that through technology and through innovation together? Couldn't agree more.
Yeah, and the other place we look to accelerate is really security, and that is, I think you talked about it earlier, right? There's bad out there.
Oh yeah.
The security threats are more sophisticated now than a few years ago, right? And they're looking for these vulnerabilities, and so it's super important that Intel and Microsoft work together to advance the state of the art for security. Because we can do all the performance, we can do the solutions, but the security has to be there as a function of that. And one of the places where we've worked together is Azure Confidential Compute.
Yes.
Right? We started out with Azure Confidential Computing and Intel Secure Guard extensions and providing application isolation that provided security in a way that it wasn't there before. And now we have these trusted domain extensions. And this is hardware-based trusted execution environments that facilitate, right, the deployment of trust domains. So this is hardware-isolated virtual machines designed to protect sensitive data, to protect sensitive applications from unauthorized and unwanted access, right? And this capability, you can go access right now in a public preview in Azure with TDX and our 4th gen Intel Xeon processor.
And Andy, let me, I love what you said and I agree with everything you said. Let me actually just simplify that for just 1 second. One thing I've heard from customers over the years is, I want to deploy something in the cloud that's super important to our organization. And it's our core IP. We want it in the cloud because we want to be able to use it against AI and ML and a lot of the great tools that are up there. But this is our core IP. We don't want anybody to actually see the computations, the actual memory, and we don't even want to take the chance that a hosting provider can do it.
Right.
That's what confidential computing is about solving. It's literally, even Microsoft, even the platform, we can't see what's going on inside of that virtual machine. That's how confidential it is.
Yeah, that's an excellent point, right? It takes away or takes out, the cloud service provider view.
Yeah.
Anybody that you don't want to give access view is gone from that, right? And that's from the hardware up, all the way through the software. And you can deploy now virtual machines, so it's actually sort of a more common way, maybe, or a more understandable way to create the security environment. You don't have to worry, or you don't have to think about how you would secure an application. You just say, okay, I want this whole virtual machine to be in a trusted environment. You just put it in there, and it's off and running.
A lot of people may or may not know this, but confidential computing has actually been, if I'm not mistaken, the brainchild of our CTO, Mark Rusinovich. I'm pretty sure he was the one that came up with it. Probably his team. I should just give the whole team their kudos. But the confidential computing team, this is something that, again, began really long time ago. Like, silicon didn't exist. This is one of those things where Microsoft and Intel said, okay, in 2 to 3 years, you're going to have silicon that does X, Y, and Z. And we're like, yes, we're going to take full advantage of it. And this is how we want to take advantage of it with confidential computing. And in fact, it's been so game-changing that there's now a confidential computing consortium. And the reason why they took that name was actually, it was the Microsoft name. We were calling it confidential computing. And they said, look, let's just keep it. That makes total sense. And now we're running with the ball, and confidential computing is available. It's in public preview today in Azure. But we have customers, and we'll talk about this in a sec, but I know we've got customers that are absolutely using it and loving it for a variety of different scenarios.
Yeah, and so, as I've talked about sort of the partnership and how we innovate and how we bring things to the market, one of the things that's just come out last year to the market was our 5th gen Intel Xeon scalable processor. Right? It's our latest processor for the data center and the cloud segment. This processor has built-in AI accelerators on every core with our Intel Advanced Matrix extensions. It has an Intel AI software suite of optimized frameworks and tools. And with that, you can achieve up to 14x or 14 times higher performance and up to 10 times higher performance per watt on AI workloads that run on your CPU. Right?
Wow.
So, that's one thing. It's designed for AI. But there are other workloads.
Sure.
Right? And so, for other workload optimization, we added more core count. We increased memory speeds. Right? And those coupled with other innovations can give you up to an 84% increase in performance just from our 3rd gen, just a couple generations ago.
Just from 3rd to 5th, 84%.
Yeah, from our 3rd gen Intel Xeon. And then, there's a lot of talk these days about, efficiency, right?
Yes.
Especially around energy.
Yes.
So our latest processor also has built-in accelerators for efficient compute. They improve total cost of ownership. This is actually, in my opinion, an opportunity for server refresh to bring some of that efficiency into your data center or into wherever you're doing compute. And then the last one really is some of the security things that we just talked about, right? You have application isolation with Intel Secure Guard extensions. You have virtual machine isolations with Intel Trusted Domain extensions. And even, in addition to that, you have this independent trust verification service for multi-cloud and hybrid cloud with Intel Trust Authority. So that you could get, it can attest to, the hardware, the security promises of the hardware all the way up through the stack. So that, again, from, the moment you press the power button to get up, you have this secure domain that you can operate within and just know that it's trusted.
Oh, I love it. Just love it.
So I talked a little bit about where we were, how we work together, how we get to innovation, and a little bit about our latest product. But what I wanted to show you, the customers out there, is what happens when you put both of those together, Intel and Microsoft. And for this example, I could have picked a number of others. I picked Intel Xeon Scalable Processor and Microsoft SQL Server. So if you're sitting on older infrastructure today, okay, you're probably sitting with a standard set of security. Maybe it has less encryption, maybe it has less protection. You mentioned shielded VMs before, so we didn't have shielded VMs in 1st gen and 2nd gen Intel Xeon processors. In the older days, administration was challenging. It was more complex. How you did policies across clouds, across data center, hybrid, it needed improvement.
Yes.
Right? And so you still might be dealing with that. And then right now in particular, you might be coming at the conclusion of some extended, some support deadline or some extended support. So as you're thinking about what should you do, how should you modernize, I wanted to give you a few data points. The first one is really around, Microsoft SQL Server 2022 and our 4th gen Intel Xeon Scalable Processor, okay? You get just this really fast real-time insights. You have up to 34% new orders per minute transactions with this 4th gen Xeon as compared to our 3rd gen Intel Xeon. Up to 28% faster queries with this in SQL Server 2022. One of the things I did want to highlight though is the security piece of SQL Server. This is now a platform that has protection to the silicon level because SQL Server 2022 added secure capabilities with Intel Secure Guard extensions that just really help the whole confidential computing, even with the database.
Yes.
Right? So, I mean, these are things that you can purchase, that you can get and pick up and then deploy. The other thing that I like about this solution together is it reduces your TCO, okay? And you can achieve up to like 114% faster database backups with our built-in Quick Assist technology,
Yep.
right? That accelerator. You were talking about how big data's gotten. Backup has become a bigger and bigger deal because it just takes a lot of time for the size of the data, to make it to all the different places that you need, so you have reliability and business continuity and so on. So this is one of the places where I think both of us listen and say, okay, we have a faster backup solution for you now, right? You had
I was just going to say on the data side, and data, the explosion of data is happening everywhere. It's happening in the cloud. It's happening at the edge. We're seeing it more in distributed edge locations. What I find interesting is hardware has gotten so powerful and so efficient, and you guys now are delivering, working with our partners to deliver these smaller form factors. I mean, now I can buy a server that's not much bigger than this laptop with lots of cores, lots of memory, lots of high-speed storage, lots of flash, high-speed networking. Plug 3 of these together, cluster them, and I've got all of a sudden a very small thing that fits in the overhead bin of an airplane. And guess what? I can do inferencing in the edge. I can run Kubernetes, I can run VMs, I can run SQL. And guess what? I want to get more data. And by the way, this data I will probably pump up into the cloud, or maybe a portion of it, maybe not the whole thing. But imagine you've got 100 locations around the world, or 1,000 retail locations across a country, where you can then bring in that data and say, let me just bring in a sample of it and let's do some machine learning. Let's do some AI against this in the cloud and actually improve our models and improve our products, improve what we deliver to the company. So that data explosion is happening. The SQL Server work that we do together and the Quick Assist, totally love all that. And it's also a perfect example of we plumb the feature at the operating system level. SQL Server then plumbed that feature into SQL to take advantage of it and to take advantage of your latest and greatest hardware.
Yeah, and what I was just stating was with our 4th gen Intel Xeon. If you want to move to the latest, right, there's a data point for you here as well. So you can get up to 2.33 times higher performance per watt with Microsoft SQL and the backup and 5th gen Intel Xeon with the integrated QAT versus our 3rd gen. I mean, this is a significant boost if you have large data sets or just large data that you need to make sure you have backed up and secure. These kind of solutions that we're innovating and delivering together, again, they're going to address a customer need and solve a customer problem.
I was chatting with Bob Ward, our architect over in SQL Server, about the QAT assist, and he was just raving. He's like, Jeff, this like opens up all, like the performance here is mind-blowing what we're seeing. And they were really excited about that work. And I know that you guys are continuing to work and accelerate in there, again, future releases. So.
That's right. So now that we've talked a little bit about something that we deliver together, I wanted to talk a little bit and go back to something we talked about earlier, which is Intel and Microsoft innovating. But we don't only innovate together. Sometimes we bring in, a customer or another partner. In this case, I wanted to talk a little bit about Beekeeper AI, right? So to improve patient outcomes and lower costs, healthcare organizations are looking to advances in the field of artificial intelligence to spur innovation. So Intel and Microsoft and Beekeeper AI, they're working together to be at the forefront of healthcare innovation, of upgrading data security and personalized patient care. Right? One of the ways that Beekeeper AI is doing this is they have a privacy-enhancing technology. This platform leverages Microsoft Confidential Compute. It leverages Intel Secure Guard extensions. It creates a zero-trust environment that protects the patient information. Okay? But at the same time, it enables precise disease identification and can even give them individualized treatment, right? So this is one of the things about unlocking the power of AI, unlocking the power of security that can use data in a way that protects patients, but also helps patients.
This is world-changing innovation here. Let's be clear here. We're talking about using technology to help patients with healthcare to deliver faster diagnoses, individual treatments, and effective care. But to do that requires access to a lot of data. A lot of data, that patient healthcare data, which is rightfully so protected by regulatory and around the world. However, this gives a way for AI to be able to take advantage of that data to help us provide better healthcare services around the world,
right,
and do it securely in a way with trusted confidential compute and confidential ledger that, guess what, that data is never accessible.
Yeah, and
this is transformative.
Yeah, and Beekeeper AI right now has already worked to validate 3 different clinical models, right? Based on this confidential computing platform that we just talked about, including one that's a COVID-19 detection tool, okay? But the possibilities, right, for different clinical AI algorithms and models it's just endless, right? This is just the beginning. And so, this is kind of where I wanted to end our discussion, is like, there's still a lot of work for us to do together for the future. And, there's just, the partnership continues to flourish, and we continue to do so much together. For my part, I just wanted to talk a little bit about what's next, at least for Intel in the Windows Server Summit. So there's some upcoming Intel sessions. There's one on accelerating SQL Server performance using Intel QAT, right? So that's one place to go look at how you can use that to accelerate your data performance on the platform, particularly with SQL. We have a Windows Server Summit presentation coming up on confidential computing in Azure with TDX, or our Trust Domain Extensions. And then we have a Windows Server modernization and optimization session that's powered by Intel.
This is really awesome. Andy, I can't thank you enough. This has been a lot of fun. I'm really glad we're able to spend some time talking about what we've been doing, not only innovation side on the Windows Server side, not only innovation that Intel has been doing on the hardware side, but the work that we're doing together. I'm excited about the future. I'm excited about what we can deliver, and I'm excited for this Windows Server Summit. So with that, I just want to say again, thank you all so much for being here at the Windows Server Engineering Summit. We are very excited about it. We hope you have a great time. We hope you learn a lot. We hope you ask questions, and I'm just thrilled. Thank you again, Andy. Thank you so much.
Thank you.
Rick, passing it back to you.
Thanks, Jeff. That was an awesome conversation you had with Andy. Thanks so much for doing it. Now, I want to get you oriented on where the rest of the content is. Go to the URL below and get a full detailed schedule of all the sessions over the next 3 days. Don't forget to ask your questions in the comment area or interact with us in chat. Go ahead and enjoy Windows Server Summit.